All right, everyone, let's go ahead and do this. This is your latest assignment. All right, start with number one, and we're just trying to find the limit. All right, so this is the limit of the function as x approaches zero. In this part right here, you be very careful of. X approaches zero from the left. So here's zero right here, or actually, zero is all along this line right here. This is zero, right? So as I approach zero from the left, so I'm going to go ahead and try to approach zero from the left. So I'm going to follow the graph. So I'm going to follow it to trace it out. Somebody said it earlier. As I'm tracing it, as I'm getting close to zero, that's my limit. Where is that at? And that's also going to be zero. Okay. Second one, oops, says I'm going to go ahead and do the same thing, except I'm going to approach zero from the right-hand side. So on the right-hand side, I'm going to trace out the function. So the function starts off right here. I'm going to follow it, and then it's going to jump up here. And as I get very, very close to zero, I'm going to be right there. That's my limit. And that also points to the y value of zero. Okay, next one, you might notice that it doesn't have a plus or minus, which means that I have to check from both sides. Okay, and from both sides, I have to check on the graph, but I can do that again, but I already did it here. I checked it from both sides, and they both say zero. So that means that my answer is going to be also zero. Okay. Next one says that when x approaches 1 from the left side. So now I'm moving from 0 to 1, which is right there. All right, so I'm going to go ahead and I'm going to do the same thing. I'm going to follow the graph. So follow it. So I'm approaching 1. Well, actually, I'm approaching 0, but then, it doesn't go anywhere there. It kind of goes up here and then comes back down here, and then it's going to keep going. So I'm still going to go towards 1, and as I get very close to 1, it's going to end up being right there, where it's going to plan on going right there, which happens to be the y value of 1. The next one, as x approaches 1 from the right-hand side. So from the right-hand side, so I'm going to follow the graph. So as I'm approaching 1, so I'm going to follow the graph. So just follow it. And as I get very close to 1, it's going to be right there. And that's going to be the y value of 0. And then when you look here, when it says x approaches 1, and we're doing it from both directions. And again, I already checked it from both directions. I checked it from the left side, and I checked it from the right-hand side. And because they don't agree with each other, now I can say that my limit does not exist. Because one from the left side, it's going to be 1. From the right-hand side, it's going to be 0. So that means that my limit does not exist. Okay. 2 from the left, 2 from the right. Okay, so next one, we're moving to 2. So as I'm approaching 2 from the left, so follow the graph. So I'm not quite at 2 yet. I'm at 0. Keep going. Keep going. I'm past 0. I'm going to 1. But I don't care about 1. It's just as x approaches 2 from the left. So I'm going to keep going. I'm going to jump down here and just keep going. And as I get very close to 2, my value of y is going to be 0. So the limit as x approaches 2 from the left is 0. Okay. As x approaches 2 from the right, you think about how can I come in towards the right-hand side? Where's the function? Where's the line? Where do I come in from? Right? And there is no line. There is no function on the right-hand side. Right? So this one right here doesn't exist. So because it doesn't exist, okay, it doesn't exist, I'll just put D and E. Okay. Because it doesn't exist, then that means from the right-hand side it doesn't exist. From the left-hand side it only exists. And so therefore this one right here, the limit from both sides, okay, this one actually doesn't exist either, because there is no coming in from the right-hand side. Okay, so the only one is just this one right here, because you can only come in from the left side. Okay, Jay says, hey, if you go directly to 0, where is your graph at? So you go directly to 0, where is your graph? So if I go directly to x equals 0, right? Where is the graph? Where does this graph live? Does it live down here? Nope. Does it live right there? Nope. That's an open circle. Does it live anywhere in here? Nope. It lives right there where the dark circle is, or anywhere there's a line or a curve. Okay, because the curve is actually a line. Or sorry, a curve actually, like that line right there, the curvy line right there, that actually is made up of a bunch of dots. So where does it live? It doesn't live anywhere except for right there at 1. So when x is 0, and you can even see it right here, when x is 0, y is 1. On the interval from -1 to 1, f of x is discontinuous at x equals, so it's saying in between here, where is this function discontinuous at x equals what? Okay, so basically follow me as I'm tracing this, right? Anytime I take my pin off, that's when it's discontinuous. So I'm gonna go ahead and start. So it's continuous, 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 and then I have to take my pin off, I have to tap that, come back down, right? So this continuous, 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 continuous. When I get to there, I have to take my pin off, come down here, and continuous, 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 continuous. You guys see that? So you saw two places where I took my pin off. One place was right here at x equals 0, and another spot was right here at x equals 1. So those are two places where the function is discontinuous. So x equals 0 and x equals 1. Okay. Number 2 says, given this piecewise function, draw the graph, right? So remember, sine of x sine of x starts off at 0, and it's going to hit the top, middle, bottom, and then middle again. And it's going to make this wave, this curve right here. The same thing over here. So it's going to go bottom, middle, top. Okay. But in this case, it's only good between -2 pi over 2, -2 pi and 0, which means that I don't need any of this other side over here. It's only good between -2 pi and 0. Okay, and let's see. It does have an underline at 2 pi, so I'm going to put a big fat 0 there, dot there. And it's open. It doesn't have an underline at 0, so I'm going to go ahead and just exaggerate a big open dot right here. Okay, that's the first one. Second one is this cosine of x. My cosine starts off like this at the top, middle, and then bottom, middle, and then back to the top. So cosine looks like a V. Like that. Okay, and then on the other side as well. So it does the same thing, but just in the opposite direction. All right, but in this case, we only want it between 0 and 2 pi, which means that anything on this side right here is gone, and we only want that side. And let's read through this. It says that we actually want it to equal 0, so right there at 0, at x equals 0, we want it to be a big old fat dot, and at 2 pi, we also want it to be a big old fat dot. Okay, that's our function. Okay, at what point does it only have the left-hand limit exist? Right? So for the left-hand side only, the only way you're going to have that happen is if you're going from the left side, and you can only come in from the left side. Jump. So the only, at what point? It's only at x equals, and this is going to be 2 pi. right? So at what point does only the left-hand limit exist? Okay, and this is only at x equals 2 pi. So the left-hand limit only exists at the right endpoint, on the right endpoint. And vice versa, or similarly, at what point does only the right-hand limit exist? This is only at the left endpoint, which is at negative 2 pi. Right? Because the only way that we can only do a right endpoint is if we come in from, the only way we can do a right-hand limit is if we come in from the right-hand side. So come through here, and that's the only one that will exist, is the only one coming in from the right-hand side. So the one at x equals 2 pi. That right there is your left endpoint. Okay. The rest of these, you can use any kind of skill you can using our 3 ways to find limit. This one, I'm looking at it really quickly, and I cannot plug 0 into the bottom, so you cannot do substitution. I'm going to go ahead and take a graphing calculator, and try to graph that. Actually, you know what? Let me see. Yeah, I think I could get this done in pretty quick. So I'm going to go ahead and graph this. I was going to make a second video just for the graphs, but this backside, but I think we can do this. So this one, you got to be very careful. You got to plug in some parentheses down here because that's 2 term. And then you got to put a bigger parentheses out here to put those 2 terms together. So I'm going to go ahead and graph it. So it's going to be parentheses 1 divided by parentheses x plus 2. Close that parentheses, minus 1 divided by 2, close that parentheses. Okay, and then divided by x. Okay. I'm going to go ahead and graph that and do zoom 6 to reset everything and see if I know what's happening at x equals 0. And you can kind of see that x equals 0. It looks like it might be less than negative 1. I'm not quite sure. I can tell it's a number, though, because it's right there where my little cursor is. But I'm going to go ahead and use my table. And again, if I plug in 0, because that's what I wanted to happen, it would say error. But I want to plug in numbers close to 0. So like 0.1, 0.01, 0.001. 0.0001. You can see what's happening. It looks like it's going to be negative 1/4, or was negative 0.25. Okay, so by graphing, I know that my answer is going to be negative 1/4. Okay, and that's the same as negative 0.25. Okay, number 2. So this one's actually something that's new. This is when x approaches infinity, meaning I want to put infinity in here. Okay, which I can't. So I'm going to have to rely on graphing to look at what's going to happen, or look at the table. So I'm going to go ahead and type it in. 2 cosine 1 divided by x. Close that. That's plus 1. Okay, just like that. And then since this is a trig function, I'm going to go ahead and do zoom 7 for trig. Enter. And what happens as I go to infinity, right? So you can see that infinity is all the way over here. You follow my cursor, right? The more I go in this way, the more it seems like it's going to be flat. And I can go to the window, and I can extend out the x max. I'm going to go to 100 and see what happens. Right, so now it's at 100. You see, as I go to 100, as I'm going further and further to 100, it looks like it's kind of flattening out. And it looks like it might be the number 2.999. And the more I go that direction, if I'm hitting the trace button, it's going to be closer and closer to 3. So I can just do it there. I can look at the table. Okay, rewind it anytime you need to for me to repeat anything. But I can put in numbers close to infinity. So infinity is at 10, no further. 100, no further. 1,000, no further. All right, you can see that as I put in more and more bigger numbers, I'm getting closer and closer, or my y values are telling me that your limit is going to be 3. So this one, my answer is going to be equal to 3. Okay, same thing with this next one, number 5. Looks like I can't plug in infinity because I don't know what to do with that, but I can plug in e to the negative x. Close that off, and then I'm going to divide all, and I'm going to put parentheses around that just to make sure that I don't screw it up. I'm going to divide all of that by x. Okay, and then again, I'm going to go ahead and do zoom 6 to reset it, because I remember I would kind of blew it up where I kind of messed around with it. And I'm going to try to see what happens as I go to infinity. Right, so as I go to infinity, you can see that it looks like it's just writing on this x-axis, right? You might not be able to tell, so you can go to the table and plug in big numbers. And you can see, like, as I'm putting in bigger and bigger and bigger numbers. That's 10,000. What happens if I put in 100,000? It says 0. What happens if I put in 1,000,000, right? So it does correlate to how my graph is. So it's going to keep following this graph here. If you follow it, right, the more and more and more I go to infinity, the further I go to the right-hand side, the more it's going to be flatter and flatter and flatter on this x-axis. So in this case, I know my answer is going to be 0 because my y value is going to be 0. Right? Okay. Number 6, this is going to be just a cosecant function. And remember, your trig identity, cosecant is 1 divided by the sine of x. Make sure you put x. Right? And then since I'm doing trig, I'm going to go ahead and do trig zoom. And what happens when I get to 0 from the right hand side? So follow my cursor, right? So as I go to 0, so I'm going towards 0 from the right hand side. Right now I'm at pi, and I'm going to keep going. And as I get closer and closer, right now I'm at half a pi, and I'm going to keep following it. And as I get closer and closer to 0 from the right hand side, it's going up higher and higher and higher. So that tells me that this limit is going to be infinity. And remember, if you have infinity, you can also write down does not exist. Okay, but if your answer is doesn't exist because they don't match each other, you can't write infinity. Okay, last one. Sketch a possible graph that has a stated properties. So it says f of 4 exists. So that means that I have to have a dot somewhere on f of 4. We'll put it right here. The limit, here we'll put it at 2. Right? The limit as x approaches 4 of f of x exists. Okay, but f of x is not continuous at x equals 4. Okay, so meaning that whatever happens, let's say whatever happens as I get towards 4, it's going to go to a number. So from the left hand side, it's going to go to a number. From the right hand side, it's going to go to a number, and it's going to be the same number. Okay, but it's not going to be continuous. So because it's not continuous, that means that I cannot have them be a solid dot. So I'm going to have them be open dot right here. Right, so from the left, it's going to be -2. From the right, the limit's going to be -2, but the answer itself at 4, it's at +2. So therefore, if you look at this graph is not continuous. And I just made it kind of fancy like that, but you don't actually even have to do that. You can keep it pretty basic. You can just say, you know, it's like this. Maybe you can do it like this. And we'll keep it at -2, but you keep it like that. Like that. Right, so from the left and right, it's going to be -2. The limit's going to be -2, but the answer is actually at